As well as good evening. This is Nikita, the Hadoop trainer. So we'll see the continuation of the class. Due to technical difficulties, I believe on the other day the class was shut in the middle. So we are going to continue from there. Okay. So if anybody has any queries, you can raise me through the chat or you can stop me. Okay. So let us go ahead with the session. What we, till now what we understood is just the need of big demo and what are the various components of big data, right? So some more differences like between RDBMS and big data technology like Hadoop. You can, whatever is present on the screen, we can view it as a differences between RDBMS system versus any Hadoop system or a smaller data versus big data. So as we discussed, the RDBMS systems are quite efficient when they are going to process gigabytes to terabytes of information, and beyond terabytes, it is something a challenge, right? And same thing, we also understood what is the difference between a centralized system and distributed system. A centralized system, you have a central server. If the databases, if the records are from various databases which are in different locations, all of them are present in a single repository only. So if you are trying to access your, the records from your mail server, it goes to the centralized server, right? If it is, for example, if it is a mail system, okay. But a distributed system appears like central to the end user, but being central, it will be distributed. Like all the relevant records may be pertaining to location or pertaining to any other factor are present in one database based on the search criteria. Like our Gmail account, right? The mail account we, or the Google, when we try to type Google, it will redirect us to google.co. and followed by our location. Like IN, it can be our US, UK or ZA, whatever. Right? What it is helping us, it is helping us to give the relevant search results. Right? If everything is we are getting from google.com, we get irrelevant search results only. As I already mentioned, if I want to search some nearby restaurants, if I'm in India, if I get some restaurants which are present in Florida or San Francisco, that is not relevant to me, right? So by being distributed, it is also providing me the relevant search results. Also, it gives me, with a very high performance. The velocity is very fast in a distributed system because it is giving me from the nearest available database server, right? The network distance becomes very low. So if the distance is low, the velocity is high, and vice versa. So this is the difference between a centralized and a distributed system. And now we have something called, structured versus different types of data. That is, RDBMS system is quite efficient when it is processing structured information. When it comes to semi-structured or unstructured information, RDBMS system, it finds it as a challenge. But here in a technology like Hadoop, you can process all the three varieties of data, that is structured, semi-structured or unstructured data, okay, quite efficiently. And here, the smaller data, the RDBMS system is a stable data model. What is a stable data model? When you define some table, it is stable, right? So all the data is stored in the form of tables in RDBMS system. Whereas here also it is a table, but it is a flat schema. What do you mean by flat schema? A stable model is something when you define a table, you cannot define it, you cannot alter it per every row. You cannot alter it per every row. What do I mean by this is, suppose I have employee table and I define some attributes here like employee ID, employee name, and employee salary. Now here, I think we discussed this, but still, suppose employee 100 is there, okay? So some name is there, ABC. He is drawing some salary, say on 300, okay? Now similarly, 101 is there, employee name is DEF, and salary is some 3,400. Now just understand, because, I have this employee DEF. Employee DEF also has mobile number. Can I include a mobile number only for this particular row? row wise, will I be able to change the attribute information or schema information? For example, ABC is having mobile number. Now, if I say I want to add mobile, e-mobile, I need to add for the entire table. It is not like, row wise I can do it. Also, in this table, I can alter this table only if everybody has mobile number. Otherwise, I have to insert a null. Right? Agreed? So that is the reason I call this table as a stable data model. The table, I term it as a stable data model because after defining the database design, it is not recommended to change the table or alter the table. Even real time also, there are very few alters happening on the table. We never do alters in production, right? We never do alters on any table. So that is the reason we keep some extra columns while we are defining the database design itself. That is altogether a different issue. Don't worry about it. But just understand, tables that we create in RDBMS are all stable. You cannot alter the schema as per the row information coming, right? For every row, you cannot alter the schema. Whereas, big data technology, like Hadoop uses NoSQL databases like HBase. All the NoSQL databases, they have a flat schema. You want to tell something, Prasad?
Yeah, yes. Can you hear me?
Yeah, I can hear you. Please go
Yeah.
ahead.
Sometimes this table can be altered, right? In some cases, not every time, right? Suppose if
Yes,
you want to add a mobile number, so we can add a column to this table.
correct.
So what you said, understand, but not every time. Some of the cases table can be altered, right?
Table can be altered, 100%, there is no doubt about it.
Okay.
But how do you prefer altering is one, this thing.
Okay. Okay.
Usually the alters are very less in production, right? You don't do alter once the table is done and
Yeah.
database is done. The reason is you have many factors affecting. If you are altering a table, the database and okay, 1 week you can sit and you can alter, or all the dependencies you can check it up, all the joins and all. But what
Sure.
about the middle layer? If you
Right.
have 100 insert query of 50 times or 60 times, you need to change all the insert query, the select query, because previously select query was retrieving some 3 or 4 results. Now you have additional mobile number in there. Update
Okay.
queries,
Yeah.
right? The middle
Right.
level, you can take it as a migration project again, depending upon the number of tables. If there are 50 to 60 tables and the middle
Okay.
layer is done, alter has so much impact.
Right. Correct.
Anyways, I am not about, here the discussion is not about actually the altering the table. What I'm
Okay.
telling is, row wise, see, you have mobile, one person is having mobile number, one
Mm-hmm.
person is maintaining mobile number 1, mobile number 2, and landline number. You
Okay.
know, the other person has some other communication details like email or fax. So
Mm-hmm.
per row, I cannot alter the table, definitely, right? I cannot keep the schema very flat that whatever communication detail employee is having, I cannot alter the table like as per the row. That is what I
Oh,
mean here,
right.
right?
Right. Correct. I understood. Right.
So if I add a mobile number, that means for the entire table it is stable. Now, if a person is not having mobile number, I have to insert a null. Otherwise, the join queries will not work, right?
Right. Correct.
So,
Yes.
yeah, that is the reason I call this as a stable model. Even if I
Stable.
alter, again, it has to be stable like that. And for every record I am inserting into the table, I have to either insert the mobile number or a null. For example, if I insert some other column, again, I have to, the table should be stable like that.
Right.
It is not like you can keep on altering the table throughout. Never.
Never. Right.
Right?
Right. Yeah.
That is the reason I call this as a stable data model.
Okay.
Okay,
Okay.
so the NoSQL databases like HBase, they are not like this. Any NoSQL database you take, all the big data technologies support NoSQL databases, especially Hadoop. On top of it, we have a database called HBase, which follows a flat schema. What do you mean by a flat schema? You can insert as many attributes as per row as you wish. There is no restriction. That is the reason I call it as a flat schema. It also follows a table structure. We'll discuss more about it when we are doing HBase. But for now, understand, you know, big data follows a flat schema. You don't have any restriction on the table, right? And you don't have the concept of joins. because you don't have the concept of multiple tables. For example, if you just come to our slide here, you can see the next, the next step, that is, you have the next statement, non-complex interrelationship. What is an interrelationship? Interrelationship is nothing but a join. Why do we have joins? Because we don't have a single table. In any project you see, at least some 10 tables you have. Okay, so 50 to 60 tables is what we have in a small project, right? So how do you have employee table, you have department table, you have some roles table, right? So you have different types of tables. Now, if you want to report from all these tables, what you need to do? You have to establish a join. So what is a join? You need to write some query. What is the prerequisite for a join? You need to have some common columns. Right? Don't worry if you don't know about joins. There's absolutely no difference. I'm just telling because in RDBMS, you store the data across tables and you try to retrieve the data from all these tables, establishing a join. Okay, but here in big data technology like HBase, you no need to have multiple tables. You can have all the data in one table only. All the data in one table only. When you have all the data in one table, do you really require a join? No. So there are no joins. Join is an interrelationship, which is complex because if you have 50 to 60 tables and if you want to join all of them, at least 70 plus lines of code you need to write. But if there is no join, if there are no multiple tables, no joins, right? No joins means no complex interrelationship, right? So these are the main advantages, okay, or differences between smaller data and big data. And all this you can term it as advantages of big data. When you are attempting any interview, all this can be questions, okay? Please mind that. And let us go to the next slide. What makes it especially useful? That is, these are the advantages of Hadoop. Now we are discussing about advantages of Hadoop. Okay, so first thing is scalability. What is scalability? Anybody? What is scalability? By the way, who is this waiting for name? I'm sorry, I did not get your name. Please, can you please edit it? Someone from the batch has not given the name. It shows us waiting for name. Anyone? Can anybody tell about scalability? Prasad, Sugandhi, or Suresh? And the other person? Yeah, Prasad. What is scalability?
No idea. I'm sorry.
Okay. Anybody else? What is scalability? Okay. Scalability is, to change the capacity of system or improving the scale of the system. Scale is nothing but the capacity, right? So improving the capability of the system is called a scalability. Now, that means the system should be in a position to scale itself. That means today I told you Hadoop is a distributed system. You have cluster of computers or you have a collection of computers. Just understand this. We have not yet gone to the cluster. Okay. So you have a collection of computers. So suppose you have 5 computers in the network. Tomorrow you want to increase it to 10. So really you can improve the scalability of the system without letting the system down for much time. You need not make the entire system down for a much time in order to improve the capacity of the system. Okay, today you have some 48 KB hard drive. Now you want to increase the memory of the system. So you can easily improve the scale of the system without really letting the system down, which is not possible in traditional RDBMS systems, right? So this is the reason scalability is a very important factor which makes it really useful, which is not possible in any of our traditional RDBMS systems. Okay. So then economical. Why it is economical? We are not using any expensive machines here. We are not using any expensive machines here. As we discussed in the demo, we are using a cluster of commonly available computers which are called commodity hardwares. Right? Commodity hardware is commonly available hardware. So we can distribute the data in parallel, and because of this, we can distribute the data among the commonly available computers. Just give me a moment. Okay, so economical because we are using commonly available computers. Now efficient because we are processing the data in parallel. When it is distributed, we can process the data in parallel. How? Let us see that. Okay, so let me take you an example. Okay, suppose you have a database. Okay, let us understand. There is a 10 GB file. You have a 10 GB file in one of the database and you want to transfer it to another database. Okay, so how much of time does it take to transfer a 10 GB file from one database to another? How much of time it is going to take? It is gonna take in hours, definitely, right? So it again depends on number of factors, right? It depends on the RAM, it depends on the capacity of these systems. Definitely, there are many factors, right? So that is the reason what I just take an assumption. It is gonna take at least an hour or 4 hours or 6 hours, depend on the system, but definitely it will take our time because 10 GB file it is. So just assumption, I'll take it as 4 hours. Okay, 4 hours required to transfer 10 GB file from one database to another database. So if I want to improve the speed with, if I want to improve, 4 hours, I cannot wait, right, for a single file. So what is the option I have? I have an option. What I do is I try to, save this file across 4 systems, okay, as 2 GB files. Okay, so previously it was only 10 GB file in one system. What I do is I'll try to put it in different systems. I'll try to split this file, okay, into 2 GB files and I'll try to save it in 5 systems. Okay, so what I do is I just copy this and save it across 5 machines. What is the advantage when I do this? The main advantage is, see this. Okay, let me take one more system. Okay, so now I have 5 systems. That means this same 10 GB file, now I have saved across 5 machines. Now if I want to transfer it to some other database, what I can do is I can process in parallel. I need not wait for anybody, right? So I can process all of them in parallel. If 10 GB is taking, okay, 4 hours of time, okay, 2 GB will take how much time? Right? Less than 1 hour, right? Less than 1 hour it takes. Okay. So if you just take 2.5 GB into 4 machines, it is going to take 1/4 of this time. That is 1 hour. Right? Now 4/5 of hour. Okay. Less than 1 hour. Right? So 10 GB is taking 4 hours. 2 GB will take
0.8 hours.
yes, 4/5, right? 0.8 it is going to take, right? 4/5 of that. So that means what? Now when I split this, it is just becoming 4/5, right? So if I make it 2.5 GB into 4, it will take 4 hours. So 1/5 of the time it got reduced. It got reduced. Previously it was taking 4 hours. It will take 1/5 of that time. So if I'm dividing into 10 days, more or less 10. So when I'm splitting into multiple files, I can process the data into parallel. This is the main idea of Hadoop, main idea of a distributed system. When you are distributing the data across systems, the main advantage is you can process the data in parallel. That means you can improve the velocity of the system. Right? By distributing the data in parallel, you can improve the velocity of the system. The speed taken here will be, 5 times the speed taken here, right? So 1/5 of the time is going to take here, less than hour, okay, 0.8 hour it is, right? And all of them are processing in parallel, so no worry, right? So this is how it is. Now, this is what I mean here. It is economical because we are processing, and we are, we don't want we need not have high configured machines here. These all are commonly available computers. In order to store 10 GB file or 20 GB file or 50 GB file, and there are multiple files in the system, you really require a high configured system. Also, the system should be high configured because you need to transfer the data from one system to another and so on. Processing, everything happens here only. But here it is not like that. I can use commonly available computers. Commonly available computers means commodity hardware. Commodity hardware means whatever laptops we are using are all, normal configuration, right? So all those with 1 TB or 2 TB machines and 16 GB or 8 GB RAM, all of them I can call it as commonly available computers. Okay, you can just have some low configured machines simply like that. That is the reason we call this as economical, and you are able to process the data in parallel. Therefore, it is very efficient. Now, you all may have one question. When you are using commonly available computers, at any point of time, the machine may fail. True, absolutely true. That is the reason what Hadoop does is Hadoop is going to maintain 3 copies of each data, because the data has to be reliable. You can't imagine if you say, today you upload one for your pic on Facebook and tomorrow you find it is no more available. Is it acceptable? No, not at all. Then how Facebook, how social networking giants like Facebook is reliably able to maintain your data, whatever video you upload or pic you upload or any post you, anything you post is reliably there all the time. You never encounter any issue, right? Your data is not available. Any pic is not available. No, not at all. If such a case, you would never look into such website again. How it is able to maintain such data reliably? Reliably means your data should never be lost, because they maintain multiple copies. Because we are using, commonly available machines here, you cannot take a chance. If you are putting data here, if you still maintain 2 more copies, your data would be reliable. Any point of time the machine is lost, a machine failed, you still have copies of data. Right? So this is what it does.
I have one
It is
question.
reliable. Yeah, please go ahead.
So if we are maintaining that copy in multiple places, then it should take more time, right? So instead of 10 GB, if we are maintaining, so we are multiplying into suppose 3 times. So that means we are maintaining 30 GB, right?
Correct.
So then it should take more time to process 30 GB data, right?
We will not process 30 GB all the time, right?
But
Suppose.
initial copy. So I am saying about initial copy.
Okay, so you mean to say the storage will take time. That is what you are telling, right?
No, in this example, suppose here we are copying 10 GB data from one place to another database. It is taking
Correct.
4 hours.
Yes.
But here in this scenario, we are splitting the 10 GB into 5 pieces, right? So,
Yes.
but we are maintaining this 10 GB data into multiple machines, so that so if any machine fails, so we can have a backup in some other machine.
Yes.
So that means we are enhancing the data, right? So it will take some time, right? So because we are copying the same data in multiple machines, so that is also some kind of copying, right?
Yes, that copying will take time, but we will not worry, because after the first copy, we will not know, we need not wait actually. Right? The storage takes place sequentially. We will discuss this more when we are discussing the Hadoop architecture. We will try to understand in detail, okay, how the file is stored into multiple copies, how the file is break down into smaller chunks. All this stuff we are gonna see. Okay. So, but understand here, yes, if you are having a 10 GB file, definitely on the system it is 30 GB, and storage, this 10 GB, it will be stored like this only, and two more copies of this file will be created on some other systems. Okay, so that part will happen. Some part will happen sequentially, some part will happen parallelly. We will see that when we are discussing architecture.
Yeah, and one more thing. So this is somewhat similar to Teradata. That is also parallel processing, right? But I know so Hadoop is taking care of semi-structured and unstructured. But
Yes,
Teradata is also similar kind of parallel processing, right? For
yes,
structured data.
correct, correct.
Okay.
Okay,
So that means so I have one more question.
yeah, yeah.
If Teradata has followed Hadoop architecture or Hadoop followed Teradata architecture?
Teradata only followed Hadoop architecture.
Okay.
The concept of parallel processing came from GFS, that is Google File System. In fact, Hadoop also followed the Google File System, right?
Okay.
After that, all databases started following it because, by distributing data in parallel, we are seeing whatever are the advantages, right? So all the systems are trying to, incorporate the same idea.
Okay.
It is from GFS actually the thing started from GFS because, the bigger data, is first dealt by Google only, right? The search engine, how it is able to search, within seconds across all databases. Because the data is distributed in parallel, it is able to search and give so many search results, that too in a very less amount of time. Also, it is able to save petabytes of information because again, it is storing across cluster of computers, right? So that part we have seen in the demo. Right. So from that system only Hadoop was developed and all the other big data technologies. There are a number of technologies in the market these days. Azure is there, HANA is there. So everybody, more or less, architecture, they are trying to get this, right? Distributed system is what everybody wants to aim at.
Yes.
Yeah. So these, when you are in appearings for some interview and all, when they ask you about the advantages of Hadoop, you can mention all this. Okay, scalability, economical, efficient, and reliable, and also the points that we have discussed in our previous slide. Okay, so when we are done with this, we are ready to go to the architecture. Okay, so let us understand the Hadoop architecture, and before that, we have to understand some terminology. Okay, so this Hadoop, we have two parts that already I told you, a storage part and a processing part. Okay, so storage part is called MapReduce. Storage part is called HDFS, Hadoop Distributed File System, and processing part is called MapReduce. Okay, processing part is called MapReduce. Hadoop follows a master-slave architecture. At any point of time, you have masters as well as slaves. Okay, so here storage part, the master. Let me put like this. Yeah, I'll take a master. You may have multiple masters also, and you will have slaves. So at both these, in the storage part as well as processing part, you have masters as well as slaves. Storage part, the master is called name node. Okay, and processing part, the master is called job tracker. You need to remember this job tracker. Okay, and the storage part, the slaves are called as data nodes. You have multiple, data nodes in the system. Similarly, the processing part is called, the slaves in the processing part are called task trackers. Okay, so every point of time you have a master and set of slaves. Okay, and along with all this, you have one more master, which is called secondary name node. Okay, secondary name node. So totally, so each and every this component, I will call it as daemon. Okay, because either master or a slave, they are nothing but a piece of software only, right? I can call it as a software process. Either the name node or secondary name node or job tracker or data node or task tracker, I can call them as processes. Okay, so they are also called as daemons of Hadoop. So totally there are how many daemons? 5 daemons. Okay, name node, secondary name node, job tracker, data node, and task tracker are 5 daemons of Hadoop. Why they are called daemons? What is a daemon? A daemon is something which doesn't exist physically, right? Some daemon is something which we cannot see, and it does some magical kind of stuff and all these things. So that is the reason they simply call this as daemons. They are software processes. Okay, this is all terminology. You can call them as daemons of Hadoop. You can call them as Hadoop processes. Okay, all of them are developed in Java only. So I can call them as Java processes in Hadoop. Okay, so now master and slave. So how do you have a master? You have a master and you have some set of slaves working under the master, right? This is called a master slave architecture. Like you have a manager, you have some set of subordinates under you. So same thing here also. This is called a master slave architecture, and Hadoop follows it either in the storage part or in the processing part. It is going to follow a master slave architecture only. Okay, this is how a master slave architecture looks like. Okay, let us discuss more about this. Now, before going that, I want to show you something, just a summary of what we understood. Yeah, I have that pic here. Let me show it. Okay, so this is what I want to just show. Just a summary of Hadoop architecture. Okay, so here see a master and slave. Storage part, you have name node and you have data nodes, right? Master and slave. Processing part, you have job tracker and task trackers, right? So storage part, it is HDFS and MapReduce, name node, data node, job tracker, task tracker, and you have one more component called secondary name node. Secondary name node, one full class we will see. We just we will not discuss it about now. The rest of demands we try to discuss now. Now see this same thing. I told you we are going to follow in Hadoop. Suppose you have a manager and set of subordinates. Okay, let me take this as either manager or master or something, and these are either subordinates or slaves, whatever you call. So S1, S2, and S3. I'll take it here. Okay, so understand one thing here. In a project, you have master and manager and project manager as well as some subordinates under him. Now, who is actually gonna code? Who is actually gonna test? Who is actually gonna develop the project? It is the subordinates, right? Manager is not going to start developing, or do the testing or whatever. Excuse me. Okay, right? So who is actually going to do the task? It is the subordinates who are going to do the task actually. Then what is the manager going to do? Manager is going to monitor the task. Once a task is allocated to the subordinates, manager has to monitor whether it is done or not. Manager has many other responsibilities. It is not like manager is going to sit idle and it is actually the subordinates who is going to do the task. Manager has many other responsibilities, many other tasks, but actual task is done by the subordinates only. Right? Agreed? Either the development or testing or whatever it may be, actual task is done by the subordinates only. Same thing in Hadoop architecture also. Let it be either the name node or job tracker or secondary name node, whatever is the master. Master has some different set of responsibilities, and always the actual task is done by the data nodes or task trackers only. Either the data nodes or task trackers only. Okay, so let me tell you one more example. Okay, let me give you one brief example. Suppose, see, you all wanted to learn Hadoop, right? So when you wanted to learn Hadoop, you did not approach me. You don't know who is Nikita and what I am teaching and all this stuff. So what you do, you are the client now. Okay. So when you wanted to learn Hadoop, you try to approach one institute which is called Bigclasses or whatever, right? So now you are the client. You wanted to learn Hadoop, so you try to approach this coordinator. Okay. You try to approach this coordinator and you tell them, okay, see manager, I wanted to learn Hadoop, right? You try to approach the coordinator or the manager or whoever is the manager in the institute. So you are the client, okay, and you wanted to learn Hadoop. Okay, now when you approach the institute, there is some manager sitting over there. What does the institute have? Institute has a manager here who will coordinate with the client. That is you. You wanted to learn Hadoop. Institute has a set of faculty associated with them. Okay, only for Hadoop? No, there are many other technologies with which the faculty are associated with this institute. So some faculty is teaching Hadoop. Okay, some others are teaching some other technology. Okay, Hadoop is there. Okay, some other faculty is teaching data science. Okay, and some other teaching some take SAP related modules and whatever. Right? So institute has set of faculty associated with them. Now, when you say you wanted to learn Hadoop, whether the institute will start teaching you, start telling you about Hadoop, whether the teaching starts whether the teaching starts the moment you ask you wanted to learn Hadoop, whether the manager here know Hadoop. No, right? What does the manager know about? What does the institute maintain? Is it going to maintain all Hadoop related data, information, everything, and will start teaching you Hadoop the moment you ask you wanted to join, for Hadoop? No. The person here, the manager here, knows nothing about Hadoop technically. What is this manager going to have? Does he have Hadoop material, data science material, SAP material, and going to share that material to you? No. The manager here maintains metadata. What is metadata? Manager here maintains data about all these faculties, right? So they maintain maybe in an Excel or in a hard copy in a book they are maintaining, we don't know about it, but they have data about this faculty. That means what? They have the faculty mobile number, communication details, right? And what are all the time slots available? Okay, what are the slots that the faculty is available, right? This type of data, not the actual data the manager has. The manager has nothing, big information or high information or whatever, right? So the manager here has the metadata about all these faculties. Nikita and some more people are teaching Hadoop. Somebody else is teaching data science. Some people are teaching SAP. Who is teaching what is having with this manager, right? And their communication details. All this data is data about data, which I call it as metadata. So institute is gonna maintain metadata. So the moment you say I wanted to learn Hadoop, the institute is gonna refer its metadata. It's gonna refer its metadata and say yes, one slot is available. A batch is gonna start shortly, so you can we can include you in that batch. So the moment you say you wanted to learn Hadoop, the manager will not start calling all these people and say, okay, are you teaching Hadoop? Are you teaching Hadoop? No, they are going to maintain on metadata because the manager may change here. If this person is going on leave, some other person may come. And when some other person comes, they cannot call all these faculties and again make this metadata. No, one central repository, they are going to maintain one metadata. Understand metadata concept here, very important. They are gonna maintain this metadata so that when I say, see, next 10 days I'm not available, very hectic in the project, I will not be able to take classes. So they are gonna update this metadata. And whenever any student comes, okay, they say now at present the Hadoop faculty is not available. Maybe after 1 week we will start the batch, right? So whoever is the manager here, they will be able to coordinate with whoever client is coming. They need not call me each and every time because the metadata is very important. Because of this metadata only the institute is running. Okay. Now, when the client says, I want to learn metadata, Hadoop, the manager is going to refer metadata and says, okay, this morning batch or evening batch is available. You can join that. And before that, in the metadata, they are going to add your information as well. That means the student information. So student ID, student communication details, everything. This is also data about data only. So all this is because they require all this for communication, right? So this metadata is going to contain not only the faculty information, course related information, but also the student information. Okay, now this is about metadata. Now once they say, okay, if the faculty is so and so is available, they will try to share a link with you. Okay, now the faculty is available. This is the time slot. This is the link. They give one channel, right? So this is the link. You please join. Okay, now they are sharing you the communication details only, not Hadoop. Nothing related Hadoop is shared with you. Then you are gonna approach the faculty with the link provided by the institute, right? Now when you approach the faculty, actual task is done here. Right? When you log into this link, we are talking only about Hadoop. Right? Now I don't talk what time you are available, what time I am available, the fee details, what are all the course details, what else, when is the batch going to start, or timings you prefer, I prefer, all this. No, we are not going to discuss anything of this. The only thing we are discussing here is Hadoop only. Right? That means what? Actual task is done at the slaveit. Actual task is done here. Nothing else. Okay, so prerequisite is client gonna approach the master. Master is gonna share some information. Based on this information, the client is gonna approach the slave. And when the client approaches the slave, the actual task is done here. So always actual task is done by the slaves, and monitoring or coordinating is done by the master. So when they share you the link, is it the master task is over? No. They have to follow whether the course is being done or completed on time, whether the relevant material is shared. They are not teaching Hadoop, but they have to monitor till the end of the course. Right? So meanwhile also, any communication is there if the faculty is not available or student is not available, they have to keep us informed. Right? So the job of the master is not ending here, but actual task is done by the slaves only. Okay, actual task is done by the slaves, monitoring is done by the master. If you are clear about this institute example, the Hadoop architecture is quite similar. The Hadoop architecture is quite similar. Okay, so now we can see that. I think just we have 5 minutes of time. Anyways, I'll start the architecture. First, we'll discuss the storage part. Okay, so very important, storing of data into HDFS. And what are the demands that come into picture? Name node and data nodes. We also have one more master node, which is called secondary name node, which we will discuss separately, not here. Okay, so here we will understand storing of data into HDFS. Okay, so the related demands. So now let me take one name node, the master, okay, and some data nodes, which are the slaves. So I will take 5 such nodes. I will not take a very big this thing. Let me take 5 machines. Understand here, all of them are machines only. Okay, all of these are machines, right? So let me put it this way. Name node is on a machine. All these are different machines. When I call data nodes, they're all in different machines, right? So all of the machines are connected. Okay, what do you call such an architecture as? Call them as a cluster, right? Cluster is a collection of machines which are connected together. Let us understand in detail about it. Okay, first of all, let me name this. This is the name node. Okay, and data node 1, 2, data node 3, 4, and data node 5. Okay, so okay, together entire systems you have 6 machines here. Okay, so such a architecture you call them as a cluster. Okay, cluster is nothing but a collection of machines which are connected together. Now here every machine is called a node. Okay, in our terminology every machine is called a node. Node is nothing but a machine. Okay, let us understand one more this thing. 30 to 40 nodes which are connected together. Okay, 30 to 40 nodes which are connected physically together and are connected through a common network switch is usually called as a rack. Okay, let me put it here. 30 to 40 nodes. This is general terminology. You need not have 30 to 40 nodes every time in the cluster. Okay, even this is a 5-node cluster, you can call it. Okay, 30 to 40 nodes which are physically located together is generally called as a rack. Okay, and collection of racks we call it as a cluster. Collection of racks is called it as a cluster. Okay, so I'll show you how does a racks look like. Racks in data center. Let us go to images. See this. Okay, so this entire thing I can call it as a rack. Okay, this is a collection of machines. You have machines here. See this. Each and everything is a machine. Okay, so and all of them are connected together. See, if you see this end this way, it looks very clean. Okay, but if you just come down, you can see all of them will be connected together. Right? See this. Okay, one side looks very clean, but the other end you have all wires. Right? They are all connected. Right? Right, like this. Okay, so this here, see this, all of them are connected. Okay, but this one thing you can call it as a rack vertically. If you see, right, this one thing you can call it as a rack, and the entire thing is a cluster. So in data center is nothing but you have cluster. But mind here one thing, this rack can be pertaining to one project. All of the racks necessarily need not be of a single project, right? Maybe you have all these racks in one project, well and good. But maybe you can also have only one rack pertaining to one project and another rack is in some different location, right? So this is all about. And the entire collection of racks you can call them as a cluster. So usually you have some 30-40 machines. Need not necessarily be. General terminology I'm talking about. When they call it as a rack, you should have 30 to 40 machines, connected together. Okay, physically located together. I call this as a rack. Okay, and entire system I call it as a cluster. I can call this as a cluster. Maybe few machines are connected together. In a few are in one location, few can be in different locations. Okay, so clear about this terminology, right? Rack and cluster and all this, and node. Okay, so tomorrow we will understand, okay, how a file is stored across this data machine, across this data nodes in multiple copies. Okay, how name node is going to coordinate, what is actually the metadata present here, what is it called, how is it stored, everything. Okay, so this is just an introduction to the architecture. Tomorrow we will see this in detail. Okay, so that's all for today. Tomorrow we are going to meet same time. Okay. Any queries? I don't, this is not the right time to take up any query actually. Maybe after discussion tomorrow's architecture, I'll take up the queries. Okay, it is too early to answer anything out of this. And once you know the architecture, most of the questions will be answered. Okay, so right now I'm not taking up the questions. Tomorrow after the architecture, I'll take up the questions, or during the architecture. Okay, so see you all guys tomorrow same time. Till then, have a nice time. Bye bye.
Thank you. Yeah.
Yeah.